Hello guys, welcome to another video. And guys, today's video we're going to be discussing about the differences between the fibrous protein and the globular proteins. Both are different types of protein. I want to be discussing, first of all, I just want to mention off straight out the bat that fibrous ones are going to be more about the structure, and globular, as we know, it's going to be more about the functionality. So where would you see globular? Well, you're going to see them in functional, so immunoglobulins, hemoglobins, where there is some functionality such as immunological function or transport function. Whereas how about fibrous proteins? Well, fibrous proteins, you'll see them somewhere where you need some type of a movement. So where in our muscles we have movement, so actin, filaments. Addition to that, I believe our bones, they have collagen. So our bones can be an excellent example. Elastin, present in, I believe, in our extracellular matrix. Not 100% sure where elastic is located. So let me, without any further ado, let me just get through this. I'm gonna first off the bat, I want to tell you guys that there is gonna be there's gonna be approximately 6 differences between the globular and the fibrous proteins. Fibrous proteins. First of all, like I said, there's gonna be a structural and a functionality difference. So I don't think I'll just highlight that again just to recap. Structure, and over here we have functionality. We have over here repetitive sequencing. So as we know, in repetitive amino acid sequences, so where do we see this? Well, we see this, of course, in the collagen. It's gonna be there's like a glutamate, a GLU amino acid. It continuously repeats. So that's something really important to know, that in collagen there's always like every third amino acid is a glutamate residue, and globular would be the opposite, so non-repetitive. Right, now the amino acid sequence, so let me just write that there. So I'll put amino acid sequence, that works for everyone. And then the next thing I will talk about is the durability. So the durability, of course, of this one is going to be that fibrous is going to be less sensitive to the changes in pH and temp. Why is that the reasoning? Well, I believe, I'm not too sure about this, but it's just because I'll probably say because of size, density, right, more sensitive to in pH. Not too sure about the reasoning though. And the next thing I'm going to talk about is going to be the I want to talk a bit about the solubility. So fibers are not water soluble, are generally insoluble, and in water, and of course globular are the opposite. So these guys are kind of opposite of each other. They're soluble. And the next thing, of course, I want to talk to you guys about is the I want to talk to you guys a bit about the examples. So the examples can be collagen, as I said, which have the repetitive sequencing, elastin, actin in the muscles, myosin again in the muscles, keratin, I believe, in the skin. Not too sure about that though. Please correct me if I'm wrong. Elastin, like I said, it was going to be in the lungs, I believe so. How about over here? Enzymes. So it's anything with functionality. Hemoglobin, immunoglobulin, and of course the big boy himself, insulin. So they're more sensitive to pH. So one thing I forgot to mention over here would be the ideally would be the, so it'd be long and narrow, and over here would be round shape. Thank you guys for watching. These are 6 differences.